I'll get started. I want to thank you guys for not beating up Walter Blood last month because he was all alone. We missed you. Whenever we're not here, we miss you guys, and thank you for coming back. So today we're going to talk about our seasonal gems, and what I like to do is take the biggest lesson learned for the year and do that presentation at the end of the year. And there was nothing more perplexing this year than check boxes. Now, check boxes should be pretty straightforward. You have a box, you check it. And that's how it was in Dev Studio. That's how it was. Someone brought up Cactus to me earlier. It's how it was in Cactus. It's literally just a checkbox. And you can add a title to it, and it's either a 1 or a 0, a yes or a no. But that's not how it was in App Studio. And there are some releases of App Studio now where your checkbox doesn't display. And Tony, I hope you're nodding your head because you were the one who found that first. And there are other times which instead of seeing one checkbox, you see a whole bunch of checkboxes. And that shouldn't be either. So checkboxes can either be created as state or value. And we're going to go over them. And I'm actually going to be live today because my machine's working pretty fast, which, saying that will probably jinx me, but I'm going to risk it. So if you, any questions, put them in the chat, put them in the QA, call out. I'll be happy to answer. So I'm going to go live because why not? I'll risk it. And the easiest way to create a checkbox is to have variables. So let's look at my maintain code. If it's going to start clocking on me immediately, then maybe we won't be live for too long. Let's see what it does. Come on, really? Okay, here we go. So I have a couple of checkboxes, and we're only going to focus on checkbox 1 and checkbox 2. So you know what? I am in the wrong place. Excuse me. I'm starting with state. I want to start with state. I have a variable called CB1 and CB2. Checkbox 1 is an integer. Thanks, Art. Checkbox 2 is an alpha. It doesn't really matter if they're integer or alpha, they're a single character. I also am going to say, okay, I can set the values of the checkbox by computing them to 1 and reset them to 0. So let's just start with this code. You'll notice even though it's an alpha, I'm still using 1 and 0 because maintain says as long as it's a number I can recommend, if I can translate, we're good. So I created my variables, I created my values. I'll create it again just to show you how easy it is to do. I'll drag CB1 onto my screen. I'll create a control, and it'll be a checkbox. But I have it already, so I'm going to just delete the one I just created, if that's okay. So here is checkbox 1, here is checkbox 2. When I look at the properties, I go down a little and I'm looking for, sorry, that's my label. When I look at the checkbox, I'm still on the label. Okay, when I look at the checkbox, I look for use value or state. State is what I'm looking for in this case because I want my state to be checked, not checked. Yes, no, 1, 0. That's all I want it to be. And when I look at the property, the settings, I have a label. So I called it checkbox 2. I could call it check me. I can call it anything I want. And when I do, that label will appear for that checkbox. So let's run it real simple. This is checkbox state. That's what I want to deal with. And again, hopefully we'll run fast enough so I won't have to kill time by telling jokes. So I have my 2 checkboxes. I can check them, I can uncheck them. I have a check button here, which was the one that computed both of them to 1. I have an uncheck, which computes them both to 0. And I have something called show me, which is just going to tell me if it's checked or not checked. Checkbox 1 is checked, checkbox 2 is not. Keeping it simple. Right there, that's where we are now. Let me go back to my presentation to make sure I covered everything I wanted to do there. Okay, you'll notice this box has no border and this box does have a border. I find it very difficult in App Studio to remove borders. So all I did for this one is I went into the properties, I located the background color, I'm sorry, not the background color, but the border color, and set it to transparent. And I'll do that for this one as well. I don't like that border. So I go into border color, and I selected the top middle, and that sets it to transparent. So that's that. Now, what if I only want the checkbox to be enabled or disabled based on a condition? So I look in my code, and I'm able to use a variable. I create CB1 disabled, and I create a variable called CB1 disabled. I have the ability to compute it to disabled or to false. If it's disabled, well, make it disabled. If it's false, make it enabled. And we've discussed how to do temporary variables and maintain, how to do settings. So again, I look at my properties form, and in my checkbox 1, in my properties for enabled, I'm sorry, I'm having trouble locating that. Here, for disabled, it's not enabled. I bring in that variable. CB1 dis. So when I click the disabled button, CB1 dis will be computed to disabled, and thus it'll be disabled. When I click enabled, it'll be set to false, thus it'll be enabled. And we can take a quick look at that because I want to show you how I'm doing it with either maintain code or with the JavaScript code. And that's important. And actually, what's the main difference there? If we're using maintain code, each time I press on a button, I do a round trip to my maintain application. I do my settings, and then I have to redisplay my form. So right now my box is enabled. Click disable, and now it's not. I can't click it. I set it to enabled. Now I can. Now I also have JavaScript built in, and I'll show that in a second for check me too. And the JavaScript does the enabling and disabling. What's great about the JavaScript is we don't have to do a round trip to the maintain server. And let's look at that JavaScript. This is using an IB composer function. In either January or February, I'm going to go over how to use the IB composer functions. This has IB composer enable HTML element, the name of it, and false. I'm getting the question of whether or not this can be visible. And just like the other options for my checkbox, there is a visible property. So if I wanted it to make it not only enabled or disabled, I can make it visible or invisible using the maintain code. And I'm sure I can do a disabled with visible or invisible with JavaScript as well. I just don't have that example here. I'll have that either in January or February when I do that presentation. So that's pretty much it. This is what we can do with a state. Okay, so that's what are there any questions about checkboxes as a state? All right, then let's go on to variable. Value. So in value, I'm creating a single checkbox called check me, CB1 again. But for my second checkbox, I'm actually making it part of a stack. and I'm giving it 3 values. Well, let's get rid of this for a second. And on my form, I have my 2 checkboxes. Again, this is now set to value instead of state. And if we look at the settings, there's no label. This is because the label is going to be whatever data is in the database. But the one thing that we're finding, or we found, is that if you assign a value checkbox to a stack, you will see all of the values of that stack. So you have to be careful. So here's my check me, which again was my value, but here are the 3 values from the checkbox from the stack, which to me, this is functioning as a radio button. So don't think I will ever use this function, but it's there. Now, when I show the values, it says that it's checked and that it's Pringle. Now it'll be blank or unchecked and whatever the value is. Just like all objects in maintain, we can pre-select the value. So if I want Walter Blood to be checked when it opens, I compute the stack.focindex to 3. And again, in my show me, I'm checking what the selected value is. And the way I can tell that the first one is unchecked is because it's blank. And I'll do that one more time. Again, Focindex is now 3. So when it displays, blood is there. I could have this be blank by not having a value as selected. And that's pretty much it. In the old days, checkboxes were literally just state. They were 1 or 0. They were easy to use. There will be times when you want the checkbox to display a certain value, but you may not want them to display multiple values. So the way to get around that is to just use a single variable and not a stack to display those values. So let me make sure I covered everything I wanted to cover. Yeah, that's pretty much it. So checkboxes can be displayed using variables as stacks, integers or alpha. Most of the time, you're just going to use them as a toggle. But if you want to display a dynamic value or a set of values, use the value property and input using a stack to display multiple rows. All right, are there any questions? Okay, then I will stop sharing and I will turn control of Art. If I use a value, do I need to retrieve from the database? In the example I just showed, the values were computed into the stack. So no, you don't need, I mean, obviously when you're running a maintain application, you may wish to use a database because that's the whole point of a write-back application, but the stack values can be either from a database or computed.
That was my question, that it seemed that you would use the value if you were pulling the values from a database, because you said you typically wouldn't use it. I would think that would be a reason why you would want to use it.
Exactly, but again, you may not want to, yes, you could, but to me, that's a radio button. So I would rather use a radio button to make a selection. What I might say is if stack.value equals this, then compute checkbox to check, or compute checkbox to uncheck. I wouldn't compute the value of the checkbox from the stack. I would test on the value of the stack and then compute the checkbox. That would be safer to me. All right.
Anyone else? All right, I guess I'll take it away. Can you see my screen? Okay, so I'm going to talk about expressions. This is basically just a recap of what expressions are, how we determine the type of expression, different behavior of where you use it, things like that. Okay, so in a world with no expressions, sounds like the beginning of a movie. Table file, car, print, dealer cost, retail cost by country, and we never need to create our own fields because we have all the information we need in the database. Yeah. So enter expressions. So we determine the expression based on the type, and the type is alpha if the result of the expression returns an alpha. So the type is all based on the format of the return value of the expression. Numeric, if I do edit of zip, if zip is an alpha and I'm translating it to a number using edit, a date field, date time field. One of my favorites are Boolean. So Boolean is just a true or false. Test equals, field 1 equals field 2. If it's true, the value is 1, and if it's false, the value is 0. Notice I say if it's true, it's not 0, because at one time, and I have to check if it's still true, we used to have a -1 for true, which was kind of odd. But as long as it was not 0, it was a true value. You can have a simple expression, which is just one field equals value, field equals field type of thing. Or you can have a compound with an if then else. Or you could have if expression 1 and expression 2. And you can get carried away. That's where all the power of the product comes in. The language itself is simple. Table file car, print or sum, your field objects, your where conditions, end. But this is where the heart and soul is of the power of Web Focus. Okay. You can have a constant expression. Constant expressions are just equal to a value. You can have an expression that equates a field to a variable or another field. Well, we already saw if then else, and then you can use the vast array of functions that we have available in order to calculate your fields. Now, if we don't have a function, and I'll probably be going over this next year sometime, we have define function, where you can take a bunch of define commands and create your own function that then is callable from any data source. It's also callable from Dialog Manager. Okay, so where can you use these? Pretty much anywhere. The sky is the limit. Dialog Manger. Wonder what happened there. So I do a dash set HW flag equals if amper date YYMD equals. Now amper date is a system variable which has a formatted date with the slashes. We can do amper date with any valid date format. It's very powerful at this point in time. So if amper date YYMD equals 2018-10/31, then it's Halloween. Otherwise, I guess HW I did for Halloween, else none. You can use it in a define. Region A10, if country equals Japan, then Asia, else Europe. Notice in Dialog Manager, you don't have a format. Everything is stored in Dialog Manager as characters, as alpha. In define, you do have to have a format. So again, that's a hint as to what type of expression this is. If it's an A, it's an alpha character. Define function, you can use expressions in define function, just like a define. Conditional joins, you need a where condition. So we join the host file at pin to identify the segment that you're joining from to, in this case, multiple job histories at pin as J1, and then we have our where condition with the where expression. Now, if this were relational and you did this join, this where condition on the where-based join gets passed to the SQL as the on predicate. So you're going to select fields from table 1, and then table 2, and then you're going to have your on emp data dot pin equals job hits dot pin. In a table request, in a compute. So just like we have define, you can do expressions. We can do expressions in compute. Here we have compute profit equals retail cost minus dealer cost. In table, you can have it on an if total, so an if is a simple expression because you can only have where a field relation and then the value. You can't go field to field. It has to be field relation value, and you can only have one of them. If you need more than one, then you can do where total, and then the full expression. And then you can have ands and ors and have a full complex compound expression. You can use expressions in a recap, similar to compute. You can use them in filter file. Filter file is just code that runs. It's a procedure that runs every time you access a file just before we start retrieving data. So in this case, I'm setting 2 filters, filter file name, clear or add, and I'm adding filter name 1, give it a description, and then you have your where phrases. And then you could have multiple filters set up. So here I'm showing you could have multiple in the middle with the ... and then up to filter name n, meaning unlimited. On recap, again, I think I mentioned that before, similar to compute. If you don't have a subfoot, the value that you compute in the recap will be shown on its own line. Or you can add your own subfoot and format it and display it however you like. So in the example, I have on sort field recap profit D6 equals retail cost minus dealer cost, and then on sort field subfoot, and then after each sort grouping, you'll see the message the profit amount is. Because it's a recap, it's going to be processed on the aggregated values. Okay, so location. Where you put your expressions matter. And we're going to talk more specifically about whether it's a define or a compute. So this slide basically shows you the order of processing when you run a focus request. And I think I put this into also for next year, so we can go into more detail. But basically, when you run a request, we're going to find the files that you're reporting from. We need the descriptions and the data. We're going to select records based on the database values. We're going to then determine the values of the defined fields. And then we're going to determine if we're keeping the record based on the where conditions on the defined fields. Then we sort the data. We prepare individual and or aggregated values. We resolve any computed fields. And then we select records based on the total tests. So if you have any where total or if total, that happens at the very end before we do the formatting of the report. Formatting is done last. So we got define and compute. One happens as you read the record. So it's record by record on the input. The compute happens on the output after you've been summed and sorted and aggregated. Okay, record selections based on real fields and defines happen with the where, again, record by record. And then the where total tests happen after everything's aggregated. So we're going to look at an example. Define file car, markup D. The D indicates it's a define. D 12.2 equals 100 times retail cost minus dealer cost divided by dealer cost. Aren't test undefines only if referenced? That is correct. So if I have a define and I define 100 fields, but I only use 2 of them in my table request, only the 2 that you reference will get evaluated. So don't think if I have 100 100 column, 100 field list of defines that you're going to waste processing time, because you're not. It's going to get parsed, but unless you physically use that field, it's not going to take up any additional processing. Good point, Art. Table file car, sum dealer cost, retail cost, markup D, and then I'm going to compute the markup C. C for compute, so we can see the difference in the values. So markup C, D12.2, is exactly the same expression for markup D. Okay, everybody sees that. There's no difference other than one's in blue and one's in red. To save space, I'm only doing for England and Japan. And here's my output. So I get dealer cost, retail cost. Markup D for England is 78.36. Markup C for England is 19.72. Now, it's exactly the same formula. So what's going on? Which is correct? Depends on what you're looking for. Okay, here's our formula. I calculate the value, and I use the values I see on the output. If I use these values, then I get 19.72, which is the markup C. So what does that prove? That proves that the compute happened after we aggregated the values. Now, how can I stop my annotating? Here we are. Close. There we go. So why are they different? Again, it's where the processing happens. Okay, I altered the code a little bit and I added a print dealer cost, retail cost, markup D by country. So now this has become a multi-verb request. So I'm doing this so I can see the detail lines as well as the aggregate lines. So here's the 7836 we saw and the 1972, but then we see the individual values for each model. So the sum version of markup D is 1954, 2052, 1948, 1883 for a total of 7836, which is the value we see over here. So the one is the sum of the values of the markups, and the other one is a recalculation of the markups at the sorted value, at the sort level. Okay, and that's what that says. And that's all I have for today. Any questions? Crickets, crickets. All right.
One thing to add in there, where grouped, which is new. The ability to actually do the where between before the compute, after you're sorting into the matrix, you can do a selection before you actually do the compute. The where total is actually doing the selection following the compute. So there is an ability to do a where underscore group now that you can actually do selection in between there.
Good point. All right,
Okay.
Mr. Blood, I see
All
no
right.
questions. You're up.
Let me share this guy. Do you see me? Yeah, I guess you do. Yeah, you see me, right? All right. Today I want to spend a little time actually talking about statistical functions and a little bit of analyze. And actually, the reason I want to talk about analyze is because in the next version of Focus that we come out with, there's going to be a new way to look at focus. And it's in development right now. And it's going to give us quite a bit of, it's going to be quite a bit of a change. So we'll be telling you about that come March and April. And that's really all I'll tell you about right now. There's something new coming, and it's going to be fun. Okay, statistical functions, analyze, let's see. Today, let's talk about functions first, and then we'll talk a little bit about analyze. This is in the world of fun statistics. The question is, where can we go beyond the prefix operators that we have that are easily available in Web Focus and in Focus? We have a lot of prefix operators that we can use to generate some of the statistical things that we might like to get. But we also have some functions that have been developed over the last couple of years, which are actually statistically related and are very powerful. So let's dive in and start taking a look at those. We'll start off with partition ref. Partition ref is a function that actually allows us to refer to a data value that is not immediately available to me. When we took a look at last is a very powerful function that we have. You've always had the ability to hold on to the last value and use it in subsequent calculation. Last is very powerful. The concept of partition ref is to not be limited by just the last, the -1, the one that the previous record. I want the value from the 3 records back. Or, as it turns out, the offset that we are actually supporting now is not only previous, we can also support offsets that are ahead of us. What we can do with partition ref is to reference something either before or after and use it in another function. The syntax actually is kind of interesting because not only does it allow me to go and get that or hold on to that data value, it allows me to manipulate it. You'll see that right after the partition ref, the first thing that we're referencing is the field, which is, yes, that's exactly what we would expect. The value from which field? Well, I can prefix that. I can use a prefix operator on that field to actually adjust. So I not only have the ability to reference the data value, I can actually perform an operation on that data value or the groups of values that thing represents. I can sum it, average it, max it, min it, count it. I then have to indicate what the sort field is. All right, and the sort field effectively basically gives us where my break is. Okay, anytime I'm working with my partition functions, and that's what this is, I'm going to be operating on a break of some point. If I don't specify it, the assumption is that you're going to use the break. The break will be the entire table. I will get all the values, and then that is my partition. The sort field allows me to indicate where the break actually is, where the partition begins and ends, and it's the date and when the data value changes within that sort field. All right. My offset is the number of records I want to go back or forward, and this is akin to the lag in SQL or the lead in SQL. So that we can actually work with records that we haven't read yet, all right, or we haven't used yet. We in fact actually have read them, but the point is that what we can do is when we're building a window with this partition, which is what we're doing, we're defining a window to lay on top of the data that we have, and we're going to basically say, okay, I want to use a record. I want to use a data value from the 3rd record back and the 3rd record ahead. So I'm going to get basically 6. I'm going to do some kind of a calculation involving the 3 records back, 3 records ahead, which is not that far. I mean, that's actually kind of an interesting thing to do. Now, partition ref basically lets me go and get this stuff. Here's a simple WF retail light simple selection where I'm actually going to go out and use a compute. Why do I have to use compute? Can I use this with define? No, not really. And the problem is we don't really have all of the information that we need. So this is going to be limited to computes, things that are post matrix. And that's what gives us the ability to go both backwards and forwards within the window that we're building. Is that we know at the time that we're doing the actual retrieval, we know where we're going, and where we're going is going to include this. And this says that I need data values before and ahead, so I'm going to actually be able to grab them and put them into a memory space so that I can use them. In this case, I'm going to take the average of the cost of goods and the product category from 2 records back. Right? And when you can see that in this particular field, I'm doing the compute, and it's actually going back and it's getting the data value from the previous, from exactly what I told it to get it, the average from the previous 2 records back, and that's what it's done. Right. So you have the ability to identify things and get them. All right. Now, partition gets a little bit more complicated than that. Partition actually allows you to get very complicated, and you can actually do quite a bit of calculation within the partition aggr function all by itself. And this is ultimately designed for rolling calculations of many, many types. The layout of the function is pretty much the same. It's something that we've seen before. We have the measure or the field that we're going to be working with, and notice that it too is prefixed. And we have quite a few prefixes that we can work with here, so that I don't necessarily have to work with just that measure. I can actually specifically ask for a total, a sum, or an average, or I can take the biggest or littlest. I can the count, all right, or the first and last. Again, my break field, is going to be the boundary of my rolling, all right, either a by or an across sort field or the entire table. Right, up to you. Next, we're going to take the starting point of the calculation. Okay, I can go n rows back or n rows forward if I want, actually, or the beginning. Right, I can position myself anyway. I don't necessarily have to be back. I can actually be one record ahead, and I'm going to roll 3 records ahead if I want that. And my ending point again is current row. I also have the ability to use the plus here to indicate the calculation, as well as the E, the end of the sort break, which would be the last value retrieved. And then finally, the rolling calculation that I can actually apply. In other words, I can apply a calculation to this grouping that I'm just doing. I'm not only doing, when we say we're doing a rolling, yep, well, we can do a rolling of lots of different things. I can do a rolling sum, I can do a rolling average, I can do a rolling max and min, all right? So this kind of capability is very powerful, and it's all in this one single function that you have available to you. So there's a lot of power in here. All right. Here's a case where we're going to take a quick look and pull out a 2-month average within the quarter. All right. And that's what we're doing. We're actually literally setting this up. We're going to use the time quarter as our break field. We're going to go back 1. We're going to go to current, and we're going to use the average. So effectively, we're going to create an average of the last 2 fields, all right, within the quarter. And that's effectively what we can do. So you have the ability to create very complicated things. There's a rolling monthly average within the quarter, which would be another thing that you can do. And you can see that it starts in each case it starts from month 1, and it does a rolling average for the 3 months that are involved. And if you want, you can actually build a rolling monthly average for within the entire table, which effectively uses the entire table as the partition. All right. It's up to you. Now, I also have the ability to use standard deviation within partition. And within what I'm going to do here is use stddp and stds, which effectively grabs and generates the standard deviation of the field. And it uses either the population or the sample. It treats it as a full population, or it treats it as a sample. And there's a slight change in the value that is created there. but it does generate the standard deviation, and you can ask for that as the operation. This is new. Now, there are a lot of other statistical functions that have been crept into our vernacular, and let's take a look at these. Let's say correlation, basically is simple. We'll take a look at the degree of correlation between two independent sets of data. The k-means cluster, which basically is a clustering mechanism which allows us to group data values. Standard deviation, this is another way to get standard deviation. Multi-regress effectively allows us to create a linear equation to fit the data values into a single equation. Outlier identifies outliers within a group, and it's based upon what we call the inner quartile range. Anything outside of the inner quartile, the inner quartiles, if I break something into 4 quartiles, the 2 inner quartiles are the 25 to 50 and the 50 to 75. Anything outside of that range is considered an outlier. So that would either be below or above. And you can identify those very easily using the outlier function. Impute has been added recently, and that's designed basically to help you deal with values for missing data. What do you do with missing data? Normally, when you're working with statistical analysis, if you have missing data in a record, you throw the record away, right? Now, that's not necessarily the best idea. In some cases, you really want to be able to hold on to that, and you can impute a data value for that missing record, and there's a number of ways to do that. And finally, we have 2 adapters that you can actually use to run functions. rserv, which basically runs connects to an R server. It's an adapter that connects to the we can use to connect to the R server, or Python. So you have the ability to run Python code or R code and call it from a focus or a web focus user function. All right. The partitioning that we build in here is used extensively. All right. And there is a set command that we use, set partition on, and you'll see that it's got 3 values there. First, penultimate, and table. The first basically will allow us to use the first sort field in a request to partition the values. In other words, the highest sort field. The penultimate allows us to use the next highest sort field to partition the values. So if I'm working in a segment and I want to partition it on the segment above that, I use the penultimate. Table allows me to use the entire matrix as my partition. Right, very straightforward. And let's take a look at some of the things that some of the partition will kick in some of these things. Correlation is very simple. All right, we built correlation in so that we can do correlation with just mentioning 2 fields. Straightforward. Use correlation, and you mention the 2 fields that you want to correlate, and run your request, and voila, you get a correlation value. All right, which may or may not be used. Now, you can obviously do grouping here and selection in order to be able to partition it down effectively. It's up to you. Right, we've got some extra noise coming in. K-means clustering allows us to basically build clusters. And the clusters will allow us to, and this idea is effectively, I want to be able to group the data that I've got. I've got a lot of data. I don't really know how to group it. And k-means cluster is a tool that you can use to actually look for the groupings. If you don't know what the groupings are, you can actually look for them. And k-means cluster is one of the mechanisms that we can do to do that. And what we do effectively is we're going to take a guess at the number of clusters that we extract. All right. And that's really what it is, because we'll ask for a certain number. And from that point on, it's up to us. We will do as well as we can based upon that number. Now, you'll notice that there are a number of other things here: the percentage of the training set size, the number of iterations or of recalculations. These are set to automatic. Right now, you can actually go back and set them to something else if you want. I wouldn't suggest it. The tolerance for the weighting value, you can set that to auto. You can set it to something else if you want. And you can, once again, you can actually take the fields that we're clustering and modify them with a prefix operator, so that you're actually not working necessarily with the original data. You're working with something that is a derivative of that values, and you can do that directly with this function. Here's a sample setup where I'm going to do a k-means cluster. I'm looking to see if I'm looking for 4 values. I'm looking for 4 clusters. All right. Now notice when I'm doing this, I'm going to put this into a scatter chart. All right, to basically see, because ultimately this is the kind of thing you have. You have data that you really don't know if there's any kind of pattern in there, and that's really what we're looking for. We're looking for patterns, right? So I'm going to put this into a chart, a scatter chart, and I want to see if I can see something that looks like a pattern. Well, if I use 4, I actually do get something like a pattern. And based upon this, we can actually see that this is coming up. If I say, I think there's 4 clusters, well, in fact, there is a way. 4 clusters does have some meaning. Notice that there are also 4 values that are way, way, way out of tremendous outliers. All right, those just exist there. But the point is that you have a way of now of clustering the data. All right, and that what's common here? Well, that's additional research, but you have a way of actually looking to see if there are clusters. Now, effectively, what we're doing when we're clustering is we are looking for the distance from a single central source, a central point. If I say there are 4 values, effectively what I'm going to have is I'm going to have 4 points in there that I say are central points. And I want to group the points, the rest of the points, based upon the distance of those points to one of the 4 points that I've set up. And the iteration that goes on goes to continually set each of these points into a cluster, go back and do the calculation again to recluster them, eventually coming to the point where I've basically come down to the point. And you can limit it. All right, you can limit it so that you don't run on forever, because it'll run as long as it can. Right. Now, standard deviation is nothing new. That's the standard deviation we've seen. Again, here, the standard deviation function that we provide, it just asks for the field that you want to use and the sampling, whether you want it to be the population or whether it's a sample. Right, and that depends upon the size of the data set that you're working with. Now, multi-regress is a multi-regression. Multiple regression is we're going to generate an equation for you, and this is standard kinds of things in to do with statistics. We're going to do it. We're taking a look at 2 fields specifically, dollars and budget dollars by date. And we're going to take a look at, see if we can generate a graph line that effectively is going to show how these things relate. And if we do that, we actually can do that. All right. And this is calculated. We can see there's a line. We're generating an equation for dollar sales, an equation for budget dollar sales, and an equation for estimated dollar sales. And these are all very tightly grouped together, but simply because the data values that we're looking at are grouped together. Outlier. All right. Where do I get my outliers from? I know I may have some outliers in the data. I don't necessarily want to include them in the analysis because it's going to skew things. It's going to make them it's going to make the numbers way off. Let's take a look. We can use outlier basically in computes and in wheres. Again, this is something that has to be done after we've grouped the data, we've done our initial selection, and we've thrown it in the matrix. At that point, we have retained an enormous amount of information. We're actually able to create which one determines which ones. We are looking for values that are greater than or less than 1.5 times the interquartile range. All right. So that interquartile range is between 25 and 75. And we're looking for data values that are 1.5 times bigger or less than. All right, and we will show them either we can specify either below or above, and when we come out, because effectively what we're doing here is we're gonna take every record and we're going to indicate whether it's above. If it's above, we're going to assign it a 1. If it's below, we're going to assign it a -1. If it's within, it's going to get a 0. And when I run this simple case, I've got, in this particular case, I've got only 2 outliers, and you can see them on the bottom. Once I've got this, I can use this data for graphing and for any kind of analysis. I can pull these out. If I need to remove these from the data so it doesn't skew the results I'm getting, I can do that as well. All right, impute. What do I do with values that are not existent, with records that don't have data? All right. When I'm calculating within a partition, I'm going to basically use impute to replace that missing value with a substitute value. Is this legit? Well, yeah, it is. As long as you know what you're doing. The issue ultimately becomes whether you can afford to get rid of the data that's in the record, if there's another data value that's missing. All right, especially if it's not one of the critical records critical fields that you're working with. All right, it's a data value carrying along, but it's not the primary thing you're looking at. Well, you can substitute using a missing value, and we can use the mean, the mode, the median, or even a numeric constant if we want. We can use this with print and list at a detail level, and we can use it with calculated values. All right. Now, with the field, you'll notice that my expression here is that my impute requires 3 things. The field that I'm going to be working with, obviously, and this has to have a missing on required. Okay, if it doesn't have missing on, nothing's going to happen. All right. The reset key basically defines the partition for the calculation. In other words, what's my range? I can use the sort field name. All right. I can use the concept preset. And in this case, it'll use the break that's already defined by set partition _on, or I can use table. And table will use the entire table. It will ignore it doesn't have a reset key. The entire table becomes the partition. Finally, we got to tell it what the replacement's going to be. Is it going to be a numeric constant? Is it going to be the mean? Is it going to be the mode? Or is it going to be the median? Here, take a look at what happens when we use, we've got partition on set to first, which is the first by value that we're going to see. And I've got returns. In this particular case, I'm going to impute my missing is going to be the median and the mean and the mode, so I can actually see what this is going to look like. In this case, I have a missing value and with my returns, and I'm using, in each case, it shows me what I would end up using with that particular value as a substitute. In other words, I'm adding this into the data. The idea ultimately with impute is to not throw the calculation off, but not lose the data values that might otherwise be used for other things. For instance, if we had a calculation that was doing doing a calculation on another field, the records that we're currently looking at, if based on returns, would be thrown out. But I want to keep them because there's another data value that I need to hold on to. Right. So this is the way you do it using impute. Now I can set it at table, in which case things are a little different. In this case, I'm setting I set it at table, I'm ending up with a different data value. All right. Now, adapters. As you know, we have literally hundreds of adapters, a lot of ways that you can get to data. In this case, I want to take a look at the rserv adapter, which allows us to go out to an R server and actually use functionality that's built in there to be able to do calculations and bring it back for use inside of our requests. I've got a simple data file. In this particular case, it's a CSV. This happens to be a wine forecast. What I'm going to build is I'm going to need a couple of things. I'm going to need a master file for that file, right? I need to be able to read that file, right? And it's going to have, in this particular case, it's going to have an access file to tell me what the delimiters are and the enclosures, right? I'm also going to need a master file for the R server, for the model that we're going to use over there, for the R code that we're going to run over there. I need to know what the input data is going to be, and you can see we have a segment just for that, and that specifies the input data that we're going to be sending over, and the output data is going to basically tell us what we're going to be receiving back. All right. Again, we have for this file also an access file that's going to tell us how this stuff is going to, where this is, where's my connection, what the script is that I'm actually going to run, all right, and what the data value is, what the data file is for that particular file. And that's here. All of these are indicated in the access file. Once I've got that set up, I can now actually use that functionality to process my data file here using the rserve function. And you can see the function basically points at the master file for the function, the input fields, all of them, and the output fields. In other words, we're pointing at the function, whatever we have to pass in, and whatever it is we're going to get back. And when we do that, okay, a couple of things. This is obviously we can only use this in compute. All right. We have to have all of the data values fully aggregated in order to use this. So we're going to bring it out of the matrix. It's not going to be something that we can do record by record on a define. We're going to get a return vector. All right. It's going to be single values coming back. We can't bring back an array. That's not going to happen. Not yet. And effectively, in order to use this, I obviously have to configure the adapter for rserve before I use it. So that would be like number one on the hit parade. And that's not, and what that will do, it's not that complicated. It will actually give us, this particular case, it's going to predict the wine prices, and it does a fairly good job of it. And it does it in a very straightforward way. Now, setting this up, the R script must read the R script must read command line arguments. Okay, the first argument has to be the name of the file. The second argument needs to be the output file, and the result field names must match the output from the R script. Okay, very important. You can see 6 steps here. This is a summarization of what you have to do to set up the server, the adapter for rserve. It's not as difficult as it looks. It's actually very simple and straightforward. Now, the same thing applies, and let me back up because I missed that. Let's back up one time. Come on, there we go. Python has exactly the same thing. All right, we do exactly the same structure for Python as we do for R. The idea is that we're going to have a master file that describes the function that we're going to be calling from the point of view of the name of the function, the parameters that are required to pass into the function, and what we expect to get back, as well as master files for the data that we're going to be applying this to. This also, like R, has to be run from a compute. You set it up in almost exactly the same way. You have to have the Python adapter set up, at which point, there it is. You're able to use it. All right, those are the functions. Let's talk a little bit about analyze. Now, analyze is analyze is for focus primarily and for code-based web focus. This is going to be a little bit more interesting with the new version, with the new way of working with focus that we're going to have in a couple of months. You can see this is very straightforward with respect to the way we code. Analyze is very much like table. As a matter of fact, it was modeled off of that. It's a command, it's a set of commands, it's a language. All right. It's a very simple language. It starts off with like modify file or table file or match file. It's analyze file. Once you've identified, that allows you to identify the file that you're going to be working with. Now, normally with any statistical analysis, you want to basically work with only numeric data, and you want to remove as much missing data as possible, or impute, do some sort of imputation so that you have a data value there so that you're not dealing with missing data, because that tends to mess up calculations. There are the stat set command is an internal command for analyze that allows you to issue sets. In this particular case, I'm going to look at things online. I'm going to allow myself to print rather than going into hold, and I'm going to turn missing on. The command to get this descriptive stats is stats. Now, this full statistical package, this exists in the focus as part of the focus language. It will operate on most files that have a master file. All right. In focus, there's actually no need to remove the alpha data because focus will ignore it. And there's no need here to load all of your data into memory in order to run, because we will do it as we process. Right.
Oh.
Yeah.
And going back to your functions that you went over, all of those need to be run as computes, right?
Yeah, pretty much.
Okay.
Yes. Yeah, and they're all partitioning. Everything is based on partitioning. And the idea ultimately is anytime we're working with a partition, we have to assume that we know all the data values that are going to be worked with. And the only point that I have that is after I've done my full retrieval. Once I got my retrieval, at that point I can, and this is with computes, I have all the data in, then I can do my partitioning, anything that's related to my partitioning. Yeah. Yeah, exactly. Good point.
It was a question from Mr. Greenhouse.
Very good. Thank you. If I run stats all, and it's going to generate for my numeric variables a whole lot of information that, and this is just a display for it. Now, there is a way, interestingly enough, that I can actually manipulate this, and I can manipulate this by bringing my my alpha fields up into my buys as buys, and it doesn't really make any difference in the order, and printing the numeric fields that I want to work with. And this is a way of preparing the file to actually be able to work with. And I want to say that because I can actually, what you saw before was working with all of the data value in GG-Sales. What happens if I want to actually group things? Can I do that? Yeah, you can. You can group so that you can actually do a statistical analysis on groups of data as well as on the full set of data. Not only that, we actually have the ability to hold the data out to a whole file with stats, which means that all of a sudden this data is now going to be accessible to something else. In other words, I can generate a file. Here, let's take a look at that. If I use option 41, and again, this is the way it's called, stats all /41, what I will generate is all the stats for all the fields, all my numeric fields in this file in whole G1. And it's going to put it into a data file with a master. And as soon as I have that, now I have a data file that I can join to something else. All right. And I can join it based upon the variable name. So all of a sudden I have a way to associate all of these data, all these calculated fields with data values in other files. And that's actually very useful. Now I can group, and you use option 40 to group. In this case, you group on the highest field. All right, you don't specify. We just use the highest field that we see. And it depends on, you can set the file up any way you want. If you want to have a numeric field there, you will. The highest field that it groups on will not be calculated on at all. In this case, we're grouping on, because I set product up, it's showing the category. All right, good. It's actually showing category. That was the highest that I'd set up. And I've got 4 values for each category field, for each of those. For coffee, for in the group coffee for dollars, I have all the calculations for I can see all of my statistical calculations. Same thing with food, gifts, etc. All right, now going beyond this, and if I can get my pointer back, there we go. I can change that to state. All right, it's very straightforward. And all I have to do to change that is to literally move the state into the first field in the file. When you generate a whole file, the by fields are always listed before the verb object. So effectively, the file that I would be looking at to create this would start out with state, right? And then it would have the rest of the values here. In this case, it's got a whole lot of values. And then I would have my dollars, my units, my budget dollars, and my budget units listed, right? All right. Analyze gives you a lot of functionality. It goes into, as you can see, analysis of variance, smoothing. There's a factor analysis, a discriminant analysis, multiple linear regression. We have a function for that. There's also polynomial regression. There's a stepwise linear regression, as well as a time series analysis, and finally a crosstab if you want to use it. This all is available through the language. This has no current front end for the GUI. However, it's going to ultimately, it is available functionally, all right, as the language. All right. Here's a simple case where I'm going to basically create a file that I'm going to operate on to do a simple correlation. I'm going to correlate the 4 fields: R cost, power, length, speed, miles per gallon, and weight. I'm going to do a correlation on those 4 fields. All right, let's take I'm taking the entire table in this case. I'm not going to group it. And you can see that when I do this, I generate a matrix that basically shows the correlation of those 4 fields in terms of how well they correlate. Whether they correlate positively, they're connected, or connected positively, they go up at the same time, or whether they move in opposite directions, whether they move together the same or they separate. Right. Again, this is available to you, and this is something that we've always had a lot of fun with. All right, that's enough for me. Any questions?
Nothing in the Q&A and nothing in the chat.
All right, we got a quiet crowd today, huh? All right, folks.
Please fill out your reviews. We really look at them and we really take information from them and determine what we're going to do next.
Yep, we do. Can't analyze, produce, define, but no. 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 Let's see, I'm looking at arts. Can analyze, produce, a define for correlation? No, not really. We need the entire data set in order to do that. And we don't have that in define. All right. All right. Standard deviation. All right. We have, as you'll see there, the note, the 19th, I believe, is scheduled to be our first of the new year. So we look forward to seeing you then. Keep your eyes peeled for the email. If you haven't gone over and taken a look at our new website, go take a look at it, ibi.com. There's a new website over there. And
At some point, there should be a new community too coming, but
exactly,
not there yet, but it's coming.
Yeah, there's a lot. We've moved through 2 companies in less than 2 years. So there's a lot of craziness. We're now part of the Cloud Software Group. We're now an independent business unit within Cloud Business Group. And before we were part of TIBCO, and before that we were an information builder. So it's been That's all been happening in the last 3 years, rather.
It's a ride.
Yeah, it's been a bumpy ride, but we're still here. Focus is still here, and Web Focus is still here, and we're still here every month to help you use the product in better and better ways. So let us know what you think. Let us know what you'd like in terms of material, and we'll see what we can do.
Follow us on LinkedIn
Yeah.
or connect with us on LinkedIn.
Yeah.
Like and share and subscribe.
Have a happy holiday season, everyone. A happy Hanukkah, Merry Christmas, Kwanzaa, whatever we celebrate in this group. We
Yeah.
hope to see you all in the new year.
Okay,
Right back at
guys.
you guys.
Bye, everyone.
Take care.